No, at one. Yeah, yes. L'he posat aquí perquè... No.
Good morning. It's a pleasure to welcome you to the last session on user-controlled glide paths. It's early, or at least it feels that way after so many days of conferencing. And today there will be 3 presentations from different focuses on some of the same issues, looking at the various operational experience, extensions to be done, and how we are going to build this new infrastructure. And it's a pleasure for me to introduce such a figurola from I2CAT.
Oops. Okay. Well, thank you, everybody. Basically, the title of this talk is a user provisioning tool for Ethernet and optical services based on UCLP v1. When I'm talking about UCLP v1, is the first version that we developed collaborating with people from Canada. However, now we have improved this version and enhanced it with a new architecture that will be explained later on at the third session today. So what keeps from the 2 presentations is the concept. However, the technology that it's being used to develop the system is different. Well, why this project? Basically because HeNet wanted to experiment with new features for users. Basically, we know that now users are becoming more active. So therefore, we have the need to give to them more functionalities. And that's one of the things that HeNet was pursuing. Therefore, this project basically adapted the UCLP system to make compatible with the HeNet network equipment. That basically was Cisco-based equipment. Also, this project attempted to provide a proof of concept to allow HeNet network users to manage their own connections by means of Ethernet connections. So it was a new way or new experience in order to see what will be the point of view of the users if they can manage their own connections. So this software provides a web-based GUI to establish, manage, and query connections controlled directly by the end user. And at the end, we provide several international demos. So I will show you 2 different use cases that we implemented, one based on the, as I said before, with the Cisco equipment, on the Catalyst 3700 and 600 boxes. And we also implemented a driver, let's say an interface to the Glimmer Glass optical switch. So users were able to manage, in one case, VLAN stuff, and the other way, they were able also to manage optical paths. Well, I suppose that most of you already know what UCLP stands for. However, I think that it's quite important just to tell you or to read this paragraph as Bill Sandernoff from Camry says. I mean, UCLP can be very simply thought as a configuration and partitioning manager that exposes each light path in a physical network and each network element associated with a light path as an object. That's important, or a service. Then that can be put under the control of different network users to create their own IP network topologies. So one of the things that we have behind the UCLP philosophy is that nowadays, from the user point of view, the network is considered as a service. However, with the philosophy of UCLP, the goal is that now the network becomes an asset. So that's one of the key goals. Then I will just describe some of the definitions that we are using in order to develop the system. Basically, we have different services. We have the light path object. That's just an abstraction of one or more light paths. I mean, as you can see here, it's just this abstraction. Then we have resource objects. Here we have an abstraction of the network interface, okay? Depending on the technology that it is being used. So Ethernet, SONET, SDH, wavelengths, so on. And then what we have is the end-to-end connection object. That basically it gathers the light path objects and the resource objects all together in order to provide the end-to-end connection. Therefore, what we have here is the terminology of federation on this, what we were using on this architecture in order to differentiate when we have different independent management domains, that each owns its own UCLP system, and they need to interact each other. So, well, As I said before, this is the old architecture that we had on the UCLP v1. So it's based on Genie and Java spaces. This one, it's no longer being supported by the UCLP, since now we have enhanced this one with a web service architecture based on WCRF. However, the prototype I am showing you today is available, and I suppose that there will be no one of problem if some one of you would like to make some tests or just evaluate what's the performance of this solution. So, what we did in order to go ahead with this project proposal? Basically, we started with a Cisco donation. I mean, what Cisco did is implemented in our labs just a maquette of what AgentNet network is, in order to be sure that we were able to have almost all the use cases that AgentNet has with his users. So basically, we had a 10 gig platform based, as I said before, with the Catalyst equipment. So all the developments well done in experimental environment in order to see afterwards if it was okay or not to move these developments to an operational environment. Well, what kind of services AgentNet was interested in, and why they wanted UCLP to provide these services? Basically, they wanted two kinds of Ethernet services that are the ones that they wanted, for example, the universities to establish by their own. One of them is the port mode BC service. It was called before the Ethernet wire service. So basically, it's a point-to-point port-based transparent service that AgentNet is using primarily to connect geographically remote LANs over their network. So that's one of the scenarios that we had to demonstrate on the use case validation. And the other scenario that we were demonstrating on this use case was the VLAN mode BC. Basically, that's a point-to-point VLAN based, and the difference is that that one is not transparent, since the AgentNet, let's say the MPLS core network, is using the same VLANs coming from the user side. Well, one of the things that we should to develop in order to enhance the features that the system we had currently had were the resource partitioning. Why? Because in case that AgentNet wants to offer these services, they have to partition the resources that they have in the network accordingly to the needs that each user wants in each connection they establish. So basically what we did here is that we create new objects. Let's say we had the parent resource objects and the LiPad objects that were the ones that had to be partitioned in sub-resources in order to assign each one of them to each one of the connections that were created. So these parent resources were manually generated, and initially they did not participate in the connection itself. However, they had information on what was the bandwidth associated in each one of the connections that were established. So as I said, each time a connection is requested, we have a partitioning of resources inside the system. So that's a graphical view of what happens. Basically, we have the parent LiPad object, and when a user establishes a connection and he's requesting, for example, 100 megabits per second, we automatically were creating a new child LiPad object that had this 100 megabits per second, and the parent was with the left bandwidth that was on this connection that could be available for the new users or the same user in order to establish new connections. Well, as I said before, this is the equipment that the system that we have developed is supporting. As I said, it's the MPLS routers from Cisco and also the switches with some modifications in order to accept the new functionalities that they were performing. Moreover, we also created what is called a new pseudo device. Basically, this object was emulating what the core network of AgentNet was, the idea is that we were creating this new object in order to emulate the MPLS core network. So this new object, the functionality it has, or the features it has, is that it was describing the border nodes of the whole MPLS core network from AgentNet. So basically, we were just working at the ends or at the borders of the network. So we are not just dealing inside on the core MPLS network. One of the developments that we did within this project is that instead of directly interact with each one of the Cisco devices through their normal interface, so we worked together with people from Cisco US in order to integrate an answer debate interface that they were developing that was based on XML in order to manage all the equipment from one point. So basically, what we did is we integrated this Cisco EDI interface inside the UCLP system, and now each time that the UCLP system is configuring the Cisco boxes is done directly through the XML interface. So it was a prototype, so we were working together in order to validate also how this interface was working and in order to check if it was interesting to go ahead or maybe to provide them some feedback on what they should modify in order to fit better with the management systems that we were working with. Well, that's a graphical representation of the system that we had. As I said, we have a web-based GUI that directly was interacting with the UCLP server. And when interacting with the Cisco boxes, this UCLP server was interacting, as I said, with the EDI servers. The ones that were directly interacting in each one of the equipments that we had independently of the interface that they had, let's say, or CLI or TL1, whatever. So this is the testbed that was implemented and that was running for some months, and all the use cases were validated with. Basically, I mean, one of the things that we did here, I don't know if it's in that picture. No, it will be in the next picture. But well, basically it's to show you the different equipment that you have and the configuration of the testbed. I think that it's not more interesting. However, I will move to the UCLP GUI that we had in order to let you know what's the benefits that it was providing to the end user and how the end user was able to create just their own connections. So we developed a new GUI interface just following the requirements that were requested for 8 people. This is, for example, the tool that is used in order to create a connection. As you can see here, the user can request the bandwidth. Then, as I said before, the user is also able to request what kind of service he wants. As I said, we have the Ethernet relay services or Ethernet wire services that are port-based or VLAN-based. Then the user is also capable to manage the VLAN number of the connections they are using. So we have also implemented a tool in order to let the user know what is the availability of the VLANs. I will show you later on. Then here we also have what is the source and what's the destination that I want to go. And moreover, we also designed, let's say, a path selection algorithm. Why? Because the user can choose if he wants the extra shortest path algorithms in order to provide a connection, or if he wants a manual selection. So it means that if we choose here manual, then the user can choose between the different options he has to arrive from the source to the destination. And at the end, we have the expiration date in order to know when is expiring the connection that we are creating. So this is the interface that we developed in order to manage the different VLANs and to see what's available, what's not, and what's used for one purposes or for other purposes. This is also a screenshot from the integration of the ADI within the UCLP system. So it's quite easy since when we were configuring the Cisco boxes, we basically were already directing all this configuration to the ADI server, and everything was done in a, let's say, fast way. Well, one of the other issues that we decided together to do in order to enhance the system that we had developed at the beginning, as I said, this system was able to manage VLAN services, well, Ethernet services by means of establishing connections with VLANs. So another thing that was proposed is why we don't also provide an interface to the Glimmer glass optical switches. Why this? Because, well, it was also interesting how we would actually directly establish light paths from the system. When I say light paths, I say pure light paths, not SONET or SDH. So we collaborated with CTVR, that's a research center from Ireland, and together we established this testbed. As you can see, this testbed also had an international connection. So we were connected from Barcelona to Ireland and also to the CTVR Research Center. And each one of them has their own boxes that afterwards could be managed or provisioned using the UCLP tool. So one of the things that we did with use CTVR is that, well, that's the logical topology of the physical topology I have shown you before. So, well, why we decided to work also with optical switches? So basically because the research team from the CTVR is working with an optical IP switching system that it's able to map the flows inside the cloud and also to define when maybe we have a bottleneck, and why not, if I have a bottleneck in my IP flow, establish a direct path, a direct lambda, let's say, to the end node in order to remove all this traffic to this wavelength for a short period of time, and then I will avoid to have bottlenecks on my IP network. So CTVR were working in this system, and what we did together is define a web service interface to them in order to allow their system to be integrated in our system. So basically, as here it says, the idea is test to use a bandwidth on demand, well, it's not a bandwidth on demand, let's say a provisioning tool like UCLP to interconnect different domains together. So the OES system was acting as a client of UCLP network. So basically, it was requesting dedicated connections, linking different OES clouds to dynamically accommodate aggregates of IP traffic flows. So as I said before, CTVR developed a tool that allowed the OES system to log into the UCLP server and request the UCLP topology in order to see what were the available topologies or let's say links to access the different OES clouds that they could have distributed along on different domains. And basically, whenever a suitable traffic aggregate towards a specific destination is encountered, then the system was establishing a direct connection to the UCLP system by means of the Glimmer glass box. So basically, we were switching from the router instead going to the IP network directly to the IP switch. And I think that here I have the picture. Here we have the router or the switch in the OES domain implementing their system. And they, for example, they had an IP network flow just from this point to this other point. So the network was mapping all the traffic, just checking the parameters of all along the traffic in order to see or detect possible bottlenecks. And it was also extracting the different topologies that the UCLP system had already provisioned. Then afterwards, when this flow was detected, the system was directly connecting to the Glimmer glass switch. So here we have a screenshot. And as we can see, the Glimmer glass switch was switching their ports in order to interconnect the traffic and now send this traffic in the light path that was created. So you suppose that the traffic can be sent really fast, avoid the bottleneck, and once this traffic or this or all the information has already been sent, automatically the light path was cut, and therefore this connection was established again. Okay. So well, that's what I wanted to tell you, the prototype that we developed together, that I think that if someone is interested in, there is no problem to get in touch with Victor. I think Victor is around there. So we have this tool already working. It's no longer maintenance provided on that tool. However, we can provide you and help you on installing it and check how it works or whatever you want. So thanks for your assistance.
Questions, comments?
Are you going to plan to introduce other platforms in this design? So not only the opticals which you presented, but also other from other vendor or other router equipment or Ethernet switching?
Yes. As I said before at the beginning, I mean, this development was done with the first version of UCLP, the one that was only supporting the ONS systems. However, now, I mean, from 1.5 years ago, we started to develop the new architecture that will be explained later on in the third talk of the UCLP system, that it's supporting, I mean, new equipment from Nortel, from Cisco as well, and now we are working also on new, we are preparing new projects in order not only to work on layer 1, but also to extend these features to layer 3, and also to work with a proposal we have with AGNet on logical routers and how we can map this in order to create different logical IP topologies and how to merge them. So we are working on it now. We have just released the second version, but I think that it's better later on to explain it, because now we were working with an old system that we stopped here the developments. Thanks.
Other comments, questions? Did the users make mistakes when they were, because you did real trials?
Yes.
Did they make mistakes when they were configuring the light paths?
Well, the mistakes, let's say that when we experiment on real environments, we are able to define and find all the bugs that later on we can find on a real environment. That's different just working in a simulation environment. And that's what we, for example, used here a maquette of what we could find on the AGNet environment in order to be sure that all the use cases and all the different things that could happen not really happened. But basically, yes, we detected many things that we were improving and we were working. I mean, this project finished by mid of 2006. So we were working for 1 year on this project. So yeah, many things appeared and we solved them.
I have a colleague who say a pair in fact beats a house of guessing. Because when you play poker, there's nothing like real experience, and this was a really interesting talk. Thank you.
Okay, thank you very much. It's okay? Okay, thanks.
It's always a pleasure to introduce one of the GN2 projects. There's so much activity going on in our community. It's been great seeing everything coming together. And of course, the Poznan Supercomputing and Networking Center is one of the main contributors. So, Radoslav Kresvary, please.
Okay, can you hear me? Anyone? Yeah, I guess. Okay, my name is Radek Krzywania. I'm from PSNC in Poland, and I'd like to present the lesson learned somehow from the JRE3 bandit on-demand system within the Gen2 project. So I will say a few words about JRE3 just in case some of you are not very familiar with that. And then I will go directly to the issues connected to the distributed system, especially system for circuit creation and the reservation of the bandwidth. So the Autobahn stands for the automated bandwidth allocation across heterogeneous network. This activity is aimed at that to connect, to allow users to automatically create circuits within the Gen2 and the NRAN. As we know, this is the multi-domain system and heterogeneous, and there's a lot of issues either within Gen and within NRANs that we need to solve to make working it together. So I don't want to get into so many details on that picture. I just want to mention that there are two very important modules there. The first one is Interdomain Manager, which is responsible for interdomain communication, performing reservation, and the interdomain pathfinding. And the second one is a domain manager who is responsible for controlling the domain and the network that stays in it. So as you can see here, we have a different technology below, and we can access them also in a different way. So we will not maybe implement all of that, but the idea is to have option to implement everything. We see how it works. So the first issue that we met starting the project was the choice of the technology. If you take a look at the giant network, it interconnects many endpoints, and each endpoint has its freedom to choose its own technology and to build its own network, whatever it is. So we have IP networks, we have Ethernet, we have SDH. We place various layers on that, and endpoints want to control all of them. The giant network itself is the SDH network based on the Alcatel devices, and we also need to go from the one point, going from one point to the other one, we need to go to the SDH network. And at the first thing, we thought it would be not very difficult or rather easy. It occurs that there's a lot of issue with the technology stitching, with agreements of the attributes. It's not so easy way to make a circuit. Even if you do it manually, calling phones and etc., it's not very easy. So we decided to limit the technologies that we are going to implement within the Gen 2 project, primarily at the layer 1 and 2, because the IP technologies are out of the scope. It's in the other activities on Gen 2 project, especially the SA3 activities and the premium IP service. So in the future, we'd like to have management of the Lambda circuits. So the layer 1, at this moment, we don't have it. And probably within the Gen 2 project, we will not be able to make such thing. For the layer 2, we are focused on the Ethernet and the SDH network, where the gigabit Ethernet is the most important one. So the number of the technologies that are available for the users is so high that it's impossible, even in 10 years, to create a system that can manage everything. So that's the main issue. The second problem that we faced was the privacy of the domain. If you take a look at your topology in your entrance or your institutions, you will see something that like is on the bottom or top of the picture. When you have the exact name of the devices, you know all of them, you know where they are located, who is responsible for them, you got contact numbers, port names, you know every parameter of the link. In fact, for some reasons, you don't want to distribute those information to other domains to build the interdomain topology view. This is required for the pathfinding, for example. That's why we invented or discovered the abstraction mechanism to hide some details of the topology. The idea was to provide as many information as is required, but not more than is needed. So we remove everything which is technical details. We remove everything which is time variant attributes, so there are changings in time. And in fact, for the links attribute, for example, we advertise just the endpoints and the capacity of the link, just to let the pathfinder and other modules know how to travel our domain. So from the top picture, we get the bottom one. When we don't know the nodes exactly, we know how to get to the domain, we know how to leave it, and we know how to traverse that domain. And this information we consider sufficient to perform the reservation. About the pathfinding, I will talk a little later, so maybe some things will be explained there. There are several approaches to making the abstraction of the topology. First is one-to-one representation, which is, in fact, giving other domains the exact view of your topology. So they know all the nodes, all the links, all the ports, everything. It has pros and cons. It's somehow the peering model. The other domain may use that information to find a circuit, so you find a circuit in one place only. But you also advertise the thing that you don't want to advertise, probably. So we have the second model, which is the aggregated one, when you hide some part of the network behind the virtual nodes and simplify the topology for the others. The another option is to represent the edge nodes only, which we choose for the Autobahn. So you take the nodes at the edge of the domains, and you show the interconnectivity between them so that other domains know how to reach you and how to traverse you if there's connection between corresponding nodes in your domains. And the last option is to show a single node only, which is also pro and cons, because you hide everything behind single node. So the domain only knows how to get to you and leave you, nothing more, which may be good for the administration who doesn't want to show too much information, but it also limits possibility of pathfinding. The information may be insufficient to make the path optimal. For the abstraction process, there is also a problem of aggregation of attributes. So at this example, we have two paths between edge nodes. One is 1 gigabit per second with a 10 millisecond delay and a cost of 45 points, whatever it is. The second one has a 10 gigabit capacity. It has 25 milliseconds of delay and a cost of 15 points. If you'd like to aggregate both the single link, you have a problem which values to choose. Because if you take, for example, the best one, so this link is 10 gigabit per second, it has low delay of 10 milliseconds and costs only 50. The Pathfinder will try to use it believing that these parameters are available. In fact, it's impossible to build a path of the 10 gigabits per second with such cost and a delay because of the real topology is totally different. So we are thinking about a few solutions to that. One of them is to limit the number of parameters that the user can choose during the reservation. So for example, he can select only the capacity and one of the other attributes, either delay or cost. This will limit the functionality of the software somehow, but it also eliminates the multi-criteria choice for the pathfinding and solve the issue of aggregation. The other option is to give the best and the worst value of the current attributes. So the pathfinder is aware that he cannot get the path that it seems from the picture. However, it complicates a lot in the pathfinder algorithm, which is not also easy to do, especially in a short period of time. So the aggregation problem is very common. It's faced in, I think, in all projects which needs to aggregate network and represent simplified view, like, I don't know, Dragon, for example, or maybe UCLP also. Okay. So now we get to the pathfinding procedures. Pathfinding approach can also vary, and it strongly depends on the representation of the network. So in that case, we know all the networks, so we have the peering model. We know all the details of the neighboring domains and the domains behind it. So the topology is open for everyone. Everyone can see what you have in your network. Then you can make a computation of in a single point in one domain only, and prepare the tailored path, which is the strict hops. So it has a pro and cons. First of all, you advertise everything in your domain, which may not be very good for the administrator or the person responsible for security. But for that, you also get an opportunity to easily calculate the path. So the implementation of such software is very easy. In the model that we accepted in Autobahn system, so we know only the abstracted topology, is advertised. You are unable to find the exact nodes that you need to use for the path. In that case, you need you can still make a single point computation, but you get a general path, which is a loose hops. And you need to ask all the domains along the path to prepare details for the path and say if it's feasible or not. So on the picture to the left, you see what pathfinders can find. It's a chain of a domain and with the interdomain links. Now, going into the each domain knows its own topology, all internals, so he can find the intradomain path which specify how to go through the particular domain. This information may be advertised, so everyone knows the exact path, or may be hidden, so all the domains know only the chains, only the chain of the domains, and each domain separate know its own path for the internal use. The third approach is the distributed computation, so it's somehow like a routing. I know if I want to go from A to B, I know only the next hop, where to send a packet to make another calculation. So there is no domain chain. The first domain is unable to find a path. He needs to send the request according to the next hop table. So he can specify his local path. He knows where it lives. So it sends a request to the neighbor domain. It does the same. And the path is built during the process of a path finding. So the path is ready at the end of the path. It's not known at the beginning. This model is quite difficult to implement. However, it's very flexible because each domain has the ability to change the path and modify according to their policy or preferences or security issues. In the Autobahn system, we decided to use the model that was shown here. So we have the abstracted topology and the details are calculated in each domain. The topologies are advertised with the Quagga advertisement, so we're using OSPF for that. To find a path, we have implementation of the Dijkstra algorithm, who calculates the shortest path according to the delay. As far as I remember, delay is the attribute that we use for the optimization. Because the information, as I said before, is sufficient to find the exact path. Each domain is responsible for its own sandbox, so he knows the details of the topology and he needs to follow that. And all the attributes are aggregated at the last domain to find a common solution for all domains along the path. The last issue that we somehow solved, or I think that's solved, is the advanced reservations or reservations for the future. Each reservation has assigned the attribute of start and end time. The resources are not configured physically. They are just booked, so we have the calendar module who keeps that these resources will be used in some time in the future. When the reservation time comes, the circuit is automatically created, and when the time expires, we close the circuit down. So again, the issue with the calendar is that you can place this model in various places. From the interdomain perspective, we can have a centralized calendar module for each domain, which will be quite difficult. For example, in a Jan2 network, when you have multiple entrants in a Jan, this approach requires that the calendar knows all the resources within the network. So the number of, and I mean that each path that is under control of the Autobahn system. So the calendar will be very big, and the administrator will not allow you also to have the information for your use. But in the contrary, it's very easy to implement and easy to maintain, and you have a single point to access that, but also a single point of failure. The other approach is to separate the calendar so that each domain has its own calendar, and the calendar is responsible for the domain only. It's also not very difficult to implement. You also solve the issue with the single point of failure. However, there are some resources that need to be synchronized, especially the interdomain links and ports that need to be synchronized between the calendars, and database synchronization is also not an easy thing to solve. From the intra-domain perspective, within a domain, there are also two approaches, the centralized and the distributed. The centralized is the one that we use in the Autobahn. It assumes that we have a single calendar module that is responsible for all resources within a domain. So again, it's easy to implement, and we have a single point of access, so no synchronization is done. The domain manager knows the network anyway, so it's no problem to give the calendar all the resources to be seen. In the contrary, the other approach is a very distributed one. So each node or each device or a group of devices have its own calendar, and the calendars keeps only the resources for a particular node. This is very difficult to implement, very difficult to synchronize, but it's very flexible and scalable. So it's also probably used in some project. As far as I know, the Phosphorus is considering this approach for the GMPLS stack implementation. Now I'd like to go through the process of reservation, how we do this step by step, based on the functional blocks of the Autobahn system. So the process is somehow similar to other solutions for the bandwidth management. However, there are some small differences, so I'd like to explain them. First of all, the user request is coming to the IDM module, and the responsibility of IDM module is to find the inter-domain path for the reservation. So we ask Pathfinder as the abstract topology database, which is built, and create the path, the chain of the domains to use. So now, since the IDM knows the chain, he knows how to, when the reservation is starting, and if he knows what is the next domain, he knows the egress point from your self domain. So he started asking domain manager to find the path from the starting point to the ending point within its domain. And the domain manager will do this, and he also asked the calendar module if the resources are available. The result of that operation, which is resulted in step 6, gives so-called constraints object, which includes the information if the reservation is possible or not, at what condition needs to be met to make it working. So for example, in the Ethernet topology, it will say that, okay, you can make the reservation from M to B, but your VLAN number must be between 100 and 200. This step, after 6, the IDM is asking the neighboring IDM domain, the domain controlled by the Autobahn, to do the same. So this step is repeated in each domain along the chain. The constraints objects are forwarded to the next domain within the request. So at the last domain, there are some kind of a puzzles to solve. So the IDM tries to fit the attributes that are the constraints to find a configuration of the circuit. So again, for Ethernet, it says that if IDM, the yellow IDM says it can be, the VLAN number can be from 100 to 200. The blue IDM says it can be from 50 to 100, and the orange IDM says it can be from 75 to 100. Then we have a choice between, the common choice of the VLAN is between a 75 and 100. So he chooses randomly, for example, the number 80, and it says that all the Ethernet domains needs to use VLAN number 80. So since the puzzle are solved, the configuration is going back to the source domain of the reservation. And this is the place where the reservation is done. Actually, I mean the reservation of the resources, not the network configuration. So again, it's the role of the domain manager. He check again the topology if it's feasible, and update the calendar status that these resources with this VLAN number at this time will be booked, and you cannot use it anymore. Since everything is confirmed and we have the reservation scheduled, the network is not configured yet. To configure the network, the calendar module is initiating the process of reservation. Some systems, like for example Dragon, is using signaling for that. So the source domain is signal to other domains that it's time to start the reservation. We decided that each domain is responsible to create its own circuit. So it's on his own. There is no signaling. There's only confirmation that the circuit is created or not. We are discussing that issue, so it may change, but at this moment it looks like that. The calendar module signal to the domain manager that it's time to make the reservation. He gives the parameter. The technology proxy is responsible for the network configuration. So here is the network configuration when the network configuration takes place. Notify the IDM, which sends the signaling to the source IDM that, okay, I have a circuit, you can use it. And the same situation is going when we are going to tear down the circuit. Again, the calendar module sends the information to the domain manager that it's time to close it. The domain manager asks technology proxy to remove the configuration of the circuit. And again, the IDM notifies the source domain that the reservation is done and you cannot use it anymore. The resources are released from calendars because they will not used anymore. So this is how we work, how it looks like. We have also the demo and the prototype who proves that this part is working. The missing thing is that we don't have a full domain manager implementation, and we don't have a technology proxy to configure the domain, the real network. We are preparing the demonstration kit for the Cambridge Jan 2 workshop, where we'd like to show this part of the working system based on the Alcatel NMS, BlueNet for AGANet, and the ASN tool from GRNet. So instead of a technology proxy and a part of the domain manager, we'll be using the real tool that are able to configure the network. This is the list of the partners that are involved in that project. So there are plenty of people of them, and they put a lot of work to make the system working and operating. So I don't want to name all the, especially the names of the people responsible for that, because the list is very long. So, okay. If you have any questions or you'd like to say something, then it's the best time to do it.
Questions, comments? Okay, I'll do a stupid question. You said that...
There's no stupid questions, there are only stupid answers.
You said that the calendaring is one of the issues because you look at network elements as a resource that can be scheduled. Could I do that from Outlook? From Outlook or sort of the normal calendaring tools? Using standard iCal or vCal protocols for that?
You need to map the resources into the calendar. So the reservation is booked on particular resources, where is the node, the port, the link, and the attributes of the link. So it's nothing personalized for a people, for a human being. So it's difficult to use such calendars. It's not this kind of...
the reason I'm asking is that it's basically the same problem as reserving a meeting room, because I want to schedule a meeting room for a certain time, and I wanted to have a projector room for 40 people. So you have sort of a resource with some attributes, and of course you would have to have many resources to build the light path. But is that something?
Yeah, it's very similar to that problem.
Okay, any good questions? There's a good question, two good questions.
Thank you. You have in your slides written each domain is responsible for initialization of circuit configuration. It means that doesn't matter if it's done manually, if it's done 1 hour before or 2 days before, and so. Wow. So you practically want to create some pool of resources, as I understood, which is after that announced to the other people that okay, so resource is ready. So. So is that similar technology, only you are not specified that it must be permanently put in the pool, these resources, as a UCLP, for example, they create a pool with which the users are playing. This is more or less dependent on the management of the networks.
Yeah, well, the difference between the UCLP and the Autobahn system is that the people who develop the UCLP always says this is not a bandwidth on demand system. I heard it many times. The side effect of the UCLP is that it reserves bandwidth. However, it's not designed for that purpose. I don't know, Sergi probably will agree with me. Or okay, so anyway, in that case, okay, in UCLP, you give the resources into the pool, and the user is able to choose, I will take this one, and connect it that way. You don't have it here. In an Autobahn system, you just say you want to go from point A in, for example, Greece, to point B in Germany. And the system is responsible to find the path to give you the resources that are used. However, it is the role of the administrator to put the resources to the pool. So each NREN and the JAD and whatever is included in Autobahn system will need to specify that you can use this link and this link and this link and advertise it to the system. So the system will know what is possible and how can I traverse from point A to point B. but the user has no control over that.
Yeah, but it's not the problem only of NRENs. It's also the problem of universities because, or the other institutions which are part of the NRENs, but they are also independent. So if you are talking about the domain privacy, so it's much more deeper than only on the level of the NRENs. Okay, it goes to every building, I would say.
Yes, that's true.
The implication of the calendaring is, I think, I'm not sure, that every domain that's participating basically is guaranteeing something to other domains. So they make their own reservation, but it's that domain that's doing it, and if it doesn't succeed, if it doesn't uphold its commitment, then the whole thing doesn't work, right? Is that?
Well, you are talking about the failure scenarios, yeah? So if we are going and the domain say that I can do that reservation from this point to this point, then everything goes back to the source domain of the reservation. The link that failed and the topology is removed or marked as unavailable, and the path is calculated again to find another path. And then the process starts again until all the paths are checked and all fails, or until we find a successful one.
But if you make a reservation that assumes a particular domain is going to fulfill this piece of it, and then it isn't able to do it, you've made a reservation 3 hours ago, and now you can't do it.
Okay, it's also a problem. The best approach to that is that you have resources dedicated only to Autobahn system, so they are always consistent with the calendar. It may happen that they are not because the administrator took some VLAN number or make a reservation from hand or anything. So in that case, there are some approach to solve it. One, we have a resiliency parameter in the reservation. We are not using it right now because we didn't implement it, but it's considered to work in that way that you make another reservation depending on the type of resiliency. But for example, you make another reservation and you keep the resource booked. So if the first part failed, you try to make another one. It may be also possible to, in case that the reservation, the configuration of the network fails, we back to the source domain again and try to find again, all the process starts from the scratch, and you try to find again another path, and all the negotiation process starts again. If the resilience is not required by the user, then if something failed, okay, it failed, and we can do nothing about it. So it depends on the network.
My question is, aims in a similar direction. If you have a reservation of a link sometime in advance, and there happen some changes, so that this agreed link to the agreed cost, agreed delay, is no longer available, will the user who booked this link be informed that he can't, that he will not be delivered with the product, or does it happen that...
You mean something like the reconfiguration of the network problem?
Sorry?
You mean something like the problem with the network reconfiguration after the resource booking?
Yeah, could happen thousands of things.
So first of all, it not happen very often, which is good for us.
Yeah.
However, each change of the network needs to be sent to the domain manager because you need to know the current topology. So it can be done automatically, getting the information from the network, looking for how the paths are built, how the links are working. It can be done manually by the administrator. But however, the DM must get the current version of the topology, an update. Based on that update, it's already implemented. He checks all the reservation, if any of the currently scheduled reservation is using the resource that has changed.
Yep.
And if so, then there are taken the steps that try to solve that issue. And we're back to the problem that I explained just a moment before. It depends if we have resilience on or off, and how we deal with that. Are we going to find another path, or we try to use the backup pack or something like that?
Now the question was whether you interact with the customer. Probably, do you tell him, oh no, the required link isn't available, but probably we have a different link with, yeah, not as good or more expensive.
No, this is not the way we're doing that, because this is research activity. So in fact, we will have a product at the end which will work, but this is not a service for the user at this moment. Mm-hmm. So we didn't pay much attention to the user interface and interaction and all the procedures. At this moment, it looks like that. When the users have a web page when he fills all the forms that I want that link from this way to this way with all parameters. As a response, he gets an email that the reservation is scheduled, or it cannot be scheduled because there is no available resources for the user, the quota is exceeded, or anything. Then he gets another email when the circuit is created and teared down. And if something fails, he also is notified with the email that there are some issues that makes that link not operating. So this is the only way to interact with the system at this moment.
Okay.
Thank you very much.
Thank you. And now we move on to the next step, articulate private networks, which is, as I understand, widely regarded as the next step in user control flight paths. This presentation is also by someone from I2CAD Foundation.
Last one.
Last one,
we promise.
Okay, Edward Grasa, please.
Okay, so I'm Edward Grasa from the I2CAD Foundation, and in this talk I'm going to present the present and the future of UCLP. If you have been here in the first talk, Sergi has talked about the old architecture. Now we are going to present the new developments, so the concept stays the same, but it's just we have improved the architecture. So a little bit of the agenda. First of all, an introduction and a high-level UCLP description for, just to clarify some terms. Then I'll try to depict the UCLP functionality through a use case that of the deployment and use of UCLP in the Jan2 and Renner scenario. In this use case, we will see the three main perspectives of UCLP. So the network provider perspective, what we call the advanced user perspective, and the regular end user perspective. And finally, I explain what are our current status of the developments and which will be the next steps. So a couple of sentences about UCLP. We call it a configuration and provisioning tool, which is built around Greek technology and web services. In concrete, it's using WSRF. So with this tool, you can do many things, but the main functionality is that advanced users can combine together various resources, being links, routers and switches, and even instrumental sensors coming from different sources to produce a wide area network which is under their control. We'll see that it's a limited control. It's just the degree of control that the owner, the real owner of these resources, has allowed the users. So all the software has been designed as a software-oriented architecture. So as I told you, we are using web services, in concrete WSRF web services. So it's really easy to integrate new networks and new network elements with just the web services approach. Also, it's kind of easy to integrate applications, instruments, devices, and sensors because all has web service interfaces. So here's a picture of what we call the articulated private network, or APN. So in a sense, it's just the user network. It's the user domain. So here, for example, we see in the bottom of the picture 3 physical domains belonging to 3 different physical networks. And now, on top of it, one can build different APNs. So the APNs are just subsets of these physical networks. For example, the first one in the middle is built from resources from domain A and domain B, but it's a network that the user sees as his own network and as his own domain. So it is, we call it that a multi-domain APN because it's built from resources from both domain A and domain B, but it's only a single management domain because all the resources belong to a single user or group of users. The same, this is a recursive process, so APNs can be built from resources obtained from physical networks or from other APNs. So a user can become also a provider of resources. So just a little bit of the description of the architecture, just high-level stuff. We have 3 different groups of web services. So we have at the bottom line of the picture, we have what we call the resource management services, which are kind of a mediation layer between the software and each one of the network technologies. So we can have the XCWS or cross-connect web service, which is the second there, the red one, which is the one that talks to network elements that perform cross-connections. So SDH cross-connections, fiber cross-connections. Then we have the VLAN web service, the MPLS web service, logical router, GMPLS, and so on. So the idea is that for each technology or group of technologies, you can always extend the framework by adding a new web service that will mediate between within the other services and this particular technology. Then in the middle, we have the resource virtualization services, because as you will see later, they are like a layer that provides still the functionality available in the lower layers, but they abstract the technology. So they present a uniform API to upper layers, so they can still act and get information of the network, but in abstracted way, so they don't have to deal with the different complexities of different technologies. And finally, at the top of it, we have different graphical user interfaces and other web services that can be built on top of UCLP. So now I wanted to explain a little bit the different main features of UCLP through a path through the different layers. So we start by the lower layer. Here we see how we achieve what we call network element partitioning. So through the use of the lower layer services, we can pick a network element and partition it in different resources. So for example, for a cross-connect network element here, we can have different resources like the slot 1 port 1, which is a gigabit interface, or even a group of channels of the slot 2 port 1, which is a SONET interface, for instance. And as we will see later, these resources can be put under the control of different users. So the switch can effectively be partitioned into multiple independent managed smaller switches. And also, all the capabilities of the switch are exposed with web service interfaces. So all the management details of the switch, like if it has a tier 1 interface, if it sends this or that parameter, are abstracted. And what you have is a high-level API, like, for example, in a cross-connect web service, you can make cross-connections and do cross-connections, query information of the switch, and so on. Now moving to the resource abstraction layer, we have what we call the logical resource web service, which was formerly called the LiPath web service, and which is a source of confusion because it's not a LiPath in the in the typical way, but it's just an abstraction of a part of a link between 2 adjacent switches or network elements, I would say. So what this web service provides is an interface to be able to access the resources of the lower layers, but without any technology-specific parameters. So you can partition this resource into smaller ones, you can bond them, you can connect several of these resources to create an end-to-end path, for example, and so on, but you just need to access high-level APIs like concatenate or whatever. So these services really act as a kind of Lego blocks that you can join together, and then when you join them and you break them, some things happen on the network. Then another thing we can do in UCLP is resource trading. So each one of these Lego blocks can belong to different users. So they can be exchanged between different users, and as I told you before, the process is recursive. So if I'm I need to be a physical network administrator to create the original resources because I need a physical network. But once they are created, they can be leased to other users, which in turn can lease them to other users, and so on. And finally, on top of all these service-oriented infrastructure, we can always create high-level services that provide services to end users. Like, for example, we can create utility web services that does bandwidth on demand over Sonnet SDH resources, or a utility web service that makes advanced reservations, or whatever service the user comes in mind. So it's really an extensible framework. So now, just after a little bit of the architecture, I'll try to make the image a little bit clearer by going through an example of the use of all this. So take this example. We have the partners of an European project that need some network resources of Gian2 and a couple of NRENs. So here we have 3 network providers, Gian2 and NREN-A and NREN-B. And then what we call the advanced user will be the network administrator, or which is usually the test work package leader of that European project. So first of all, we're going to see the software from the network provider perspective, so either from the Gian2 or each one of the NREN's NOC perspective. So what they can do with the software is the software has a graphical user interface that acts like a typical network management system. So they can create a graphical model of the physical network with all the network elements and physical links. And the information will be retrieved from the network elements and kept up to date. So if the configuration of the network changes, this will be reflected on this interface, and can use this administrative interface to operate the network the traditional way. So they can go in the network elements and create and delete connections. They can monitor the physical network and see if there are any problems, like this connection should be here, but it's not. Or they can see all the connections in the network, and so on. But apart from this, it provides the UCLP services, let's say. So physical network administrators can take resources can create resources from the network. So they can take a group of physical links or interfaces and assign them to a certain user or group of users. Or they can either take these resources and use them, so the physical network administrator can also create logical resources for internal use. Okay, so with this picture we see what's the management interface of the physical network administrator. So we see there's an example picture of a simplified Gian2 topology, and there is where you would have your network elements and your links. Here, for example, it's shown a network element is selected, and you can see at the bottom of the picture all the links from and to this element. And here, what these pictures illustrate is the physical network administrator creating a logical resource. So, for instance, the physical network administrator can click in any of those links and select. Here, it's an SDH link, so it sees all the STM1 channels from 1 to 64, and can choose which part of that physical link he's going to allocate to a certain group of users. So it is important here that nothing happens on the network element. It's just that a logical resource, so a kind of a proxy for the users to interact with the equipment is created. So as you see here, we had the physical network of Jan2, and here in the right, at the background of the picture, we see the same network, but now we see the logical view. So here we see all the logical resources that are being created for users. So this arrow here between the node in Spain and the node in France shows that there is a logical resource which is part of a link between these two nodes. Okay, so the network element administrator can keep on creating resources, and at the end what it has is a resource list that will give to a certain group of users. So here, for example, it has created this resource list with all these partitions of physical links, which are the arrows between nodes, and the interfaces, which are the little arrows in each node. So it has created all these resources, it will put them in a resource list, and it will send them to the user so that the user can use all the resources himself without having to talk to the network element administrator, to the physical network administrator again. So here, for example, it would enter the name of the organization where these resources will be given or raised, and that's it. So at the end, what the physical network administrator does is he creates different resource lists. So we can see here, the different, at the left, we can see in the resource list, we can see that there are 3 resource lists for 3 different users. So at the right, we have a schema of what is happening in the network. What we are doing is each resource list here is represented by a different color. So we are taking our physical network and we are partitioning it into smaller networks that are put under the control of different users. So we are taking one big physical network and we are decomposing it in several networks that are controlled by different users. So now we have seen a little bit the network provider perspective. Now we will see what can the advanced user that receives all these lists do. So this advanced user, which would be in this example would be the work package reader of the testbed project, the testbed work package, sorry. He would receive all these resource lists and he can create new resources. For example, if he receives an interface that ends on one switch and an interface that ends in another, and they know they are connected, he can create a new live web service out of these 2 adjacent interface web service. And he can use the logical resources himself, so he can create the connections he wants over these resources and do them, so he can change it. He can play with the resources to create different topologies that they will suit their needs. And what he can do is list the logical resources to other users or have its end users use these resources through the use of high-level services. So he could, for example, have a bandwidth on-demand service that offered a simple interface to the end user, like I want a connection from here to here. But the particularity would be that this bandwidth on-demand service would work on top of these logical resources that the advanced user receives. So he can play both roles. He can be either a network operator or also a network user. So here we see how it's the graphical user interface for the advanced user. It's the same one, but the only difference is that it cannot create or play with physical networks because he doesn't have anyone. So he can just use all these resources and create different topologies. Here, for example, we see the resource list that Jan gave to the user, but if you remember in the example, there were also 2 NRENs, NREN A and NREN B. So on the left side, you can see the 3 resource lists at the beginning, NREN A for European Project AA, and so on, that are the 3 separate lists of resources that he received. And what the user can do is combine all the resource lists into a new one, which is the one here that is shown in the picture. So what the user has done is integrate resources coming from separate management domains to its own management domain. So the user sees all these resources from different networks as a single network and that is under his control. So this picture is the picture on the left, which again we have at the bottom the three physical networks, the NREN2, GN2, and the NREN1, which have given a subset of their resources through these three resource lists in the middle, and the user has joined these three resource lists to create a multi-domain APN where he can change the topology, he can connect the resources in any way he wants. So then what he can do with this is just, take the graphical user interface and just create connections over the resources, or have an application interact with the resources, or use one of these high-level services I have talked at the beginning, like the APN scenario service, which is the one we have first developed. This service, what allows you to do is to define a set of pre-configured topologies over the resources you have. So you can have an APN scenario 1 where you have 3 connections in some way. Then you have the scenario 2, which you have another way of connecting the resources. And then when you deploy this service, what you have is a web service that has a very simple interface that just allows you to tell him what scenario you want to configure and at what time. So when the time comes or when someone invokes configure this scenario, all the connections that were defined on this scenario are put in place. And same thing, when they change the scenario, the connections from scenario 1 are removed and connections from scenario 2 are put in place. So now the last user or role we have in the system is the regular end user perspective. So this user is the end user that doesn't want to handle all this complexity, because of course the user can have more control, but it comes to the price that it needs to be a little bit more knowledgeable, because it needs to do a little bit more of work. But you still have these end users that just want to use that high-level services, like I want a connection from A to B with that megabytes, and that's it. Or for example, I just wanted to execute this scenario and I want my connections put in place. So you still have place for that kind of users. And this system, what allows them to do is to have a richer set of services available to him. So you can have a bandwidth on demand system on top of UCLP, but you can of the other services, but you can also have this APN scenario service, reservation service, and so on. And developing these services is simpler than if you had to do it from scratch, because you have all the underlying structure that deals with every specific technology and every specific network element. So the idea is that the user can have a richer set of services in an easier way and at a lower cost. So which is our current status and next steps? Right now we are trying to provide a commercial edition of UCLP. This doesn't mean that the code will need to pay for the code, but we will still be providing all the code, open source and free. We'll just be providing support and more frequent updates to the people that subscribes and pay. So, sorry. So we have here the different types of subscriptions. Well, the first one is just what we call UCLP open source. This is just the forge. So the web page where all the source code and the repositories for the source code of all the services will be maintained. And this page will also have tools to allow collaboration. So if you want to extend one service with a new feature or add a new network element or create a new service on top of UCLP or whatever, we really welcome you to join our community and extend all the UCLP software. Then we have what are the real subscriptions. So we have the UCLP Community Edition. The first release of this Community Edition will be launched on June 2007. And it contains a software appliance. So it contains an embedded Linux operating system that installs itself with all the software that UCLP requires to work, and provides the user interface as well as an administrative interface, a system to notify bugs and so on. This subscription is free, but it comes with no support and no maintenance, and updates are every 6 months. Then we have the business edition, which will come in more or less September 2007, beginning of autumn, I would say. So it has the same software, but we provide standard support, and the updates are more frequent. And we also, the appliance the administrative interface is enriched with a system to monitor all the services and you know, the consumption of RAM memory and so on, so you can see if your system is about to collapse, or you can still create more resources and more network elements on it. And finally, we have the Enterprise Edition, which will come at the end of this year. So it's basically the same as the Business Edition, but it has features for online shopping, accounting, and branding. So this edition is targeted to organizations that want to use UCLP and charge their users to use UCLP. This comes also with standard support and frequent updates. This is just a screenshot of the appliance interface and the administration interface. So here you can start and stop the services, get the updates, schedule reboots, and so on. So here's the current status. We right now support just SONET with continuous concatenation and target Ethernet. Well, the first release of the community edition, which will be done by the end of June, will support also SDH. And right now we support the Cisco ONS 15454, the OME 6500 from Nortel, and the HDXE from Nortel. And the available utility services, that services that provide end-user functionality, is just the AIPN scenario service. And the UCLP release that will be available sooner is the community edition. So future activities, we want to keep adding support for more network elements and more technology. We will be starting a project with AGANet and any other partner that wants to join. That is called the Manticore project, that wants to extend these same concepts to layer 3. So we want to provide the user with the ability of create its own customized IP network, where the user will be available to choose the route and configure the routing protocol, who they want to peer with, and things like this. And this will work over physical as well as logical routers. We also want to add support for SDH. Well, this will be done in 2-3 weeks. MPLS, Ethernet. So pretty much because the concept is extensible to any network technology, we want to do as much as we can. We also want to add more utility web service. In this activity right now, a network reservation system for UCLP is under development. And an adapter will be developed so that this network reservation system is compliant with the Phosphorus project, in which the I2K Foundation is participating. And finally, we are starting to create a UCLP group that, together with Inosight Technologies, which is the commercial head, let's say, of our group, can provide professional UCLP solutions, so support, training, customized service, and so on. So thank you very much for your attention. If you want more information, here you have some pointers. You can also go to our booth, but maybe it's a little too late now. And if you want, we still have free CDs with all the software appliance, the graphical user interface to distribute, so they are free for you to install and test. And if you have any suggestions or you find any bug, we'll be very happy to hear your feedback. So thank you very much.
Thank you. Did you discuss the possibility to test this tool in frame of Gen 2? I mean, in the test bed which Gen 2 is building, or in a real network with the NRENs, and generally for the control Gen 2 plus, I would say, if you know what the Gen plus means. Okay, it's the end-to-end services which Gen 2 provides for the NRENs.
So the question if we are wanting to test this over the real Gen 2. So the question is if we want to test this over the real Gen 2. Yeah, oh, we would be delighted to do this. So if.
Yeah, but my question is, if you started negotiation with the responsible people for the administration of Gen 2 Plus.
Well, if someone is in this room, we could start now, but we haven't yet. But we would be delighted to do so. So as many interactions and collaborations we can have, the better for us.
Other questions?
It's again my remarks, not the comment, no question. So it's a pity that there are not these people.
Any other questions or comments? Let me say thank you.
Thank you.
And this concludes the user control live presentations. There's coffee and there's a closing plenary over at the Oticon.